Hello everyone. Today, we're diving into one of the fundamental pillars of discrete mathematics, combinations. In math, a combination is the process of selecting items from a set where the order does not matter. Introduction and definition. This is the golden rule you must remember: in a permutation, order is everything. AB is different from BA. In a combination, order is not important. AB is exactly the same as BA. Imagine you are choosing 3 friends from a group of 10 to go to lunch. It doesn't matter whose name you call out first, the group remains the same. That is the essence of a combination. Mathematical logic and formula. To calculate the number of combinations of R objects from n available objects, we use this formula. You might wonder, why do we have to divide by R? At the bottom, let's break down the logic. If we pick 3 letters A, B, C in a permutation, the sequences ABC, ACB, and so on, are treated as 6 distinct events. But in a combination, all 6 of those arrangements are considered one and the same. Since 3 objects can be arranged in 3, which is 6 ways, we divide the total possibilities by 6 to eliminate these duplicates. This is what makes combinations leaner than permutations. Case study: the handshake problem. Let's look at a classic example, the handshake problem. If there are 10 people in a room and everyone shakes hands with everyone else exactly once, how many total handshakes occur? This is a combination problem because a handshake between person A and B is the same as a handshake between B and A. Computing applications and repetition. As a computer science student, combinations are crucial in several areas. 1. Cryptography, analyzing how strong a password is against brute force attacks. 2. Recursive algorithms, used in backtracking techniques to find every possible solution to a problem. 3. Combinations with repetition. If you are allowed to pick the same object multiple times, like picking 6 donuts from 4 different flavors, the formula shifts to Cn plus R1, R. Introduction. The power of selection. The fundamental rule of a combination is simple: order does not matter. If you are picking a team of 3 people, Alice, Bob, and Charlie, it is the exact same team regardless of whether you picked Alice first or Charlie first. In a world of permutations, order is king, but in the world of combinations, the result is all that counts. The logic behind the formula Cn, R equals frac n. R, nr, appears. Let's look at the math. The formula for Cn, R, often read as n choose R, looks a bit intimidating at first. But notice the denominator, R, nr. Why do we divide by R? Think of it as a correction factor. If we were calculating permutations, we would have too many results because the arrangement ABC would be counted separately from CBA. By dividing by R, we are mathematically collapsing all possible arrangements of those same R objects into a single, unique group. This ensures that we only count unique sets, filtering out the noise of different sequences. Deep dive, combinations with repetition. But what if you can pick the same item twice? This is called combination with repetition, and it's a favorite in computer science problems. Imagine you are at a bakery buying 6 donuts, but there are only 4 types available. You could buy 6 of the same type, or a mix. Combinations in probability and data, graphics showing a deck of cards or a network graph. Combinations are also the backbone of probability. If you've ever wondered about the odds of winning a lottery or getting a specific hand in a card game, you're looking at combinations. In data science, we use combinations to understand sample spaces. When we test a hypothesis, we need to know how many different subsets of data could have been chosen from the master set. Without combinations, we couldn't accurately measure statistical significance. Even in graph theory, calculating the number of possible connections in a social network uses Cn, because a connection between user A and user B is a single, mutual link. Conclusion. Beyond the numbers, to conclude, remember that combinations are more than just a formula in a textbook. They are a logical framework for filtering out unnecessary order, organizing complex sets of data, predicting outcomes in an uncertain world. As a student of mathematics and computer science, mastering this concept allows you to write more efficient code, build more secure systems, and think more clearly about the structures that surround us. I am Anugrah Alexander Montolalu. Thank you for joining me on this deep dive into the logic of selection. Keep practicing those factorials, keep questioning the order of things, and as always, keep learning.
Na muna at ako'y mag-isa.